let's talk about this device. Now, have you seen this device somewhere? Maybe in some famous TV show or something else? Now, let's see what happens when you make the contact with this device. Now, as you touch this device, the first impression is the hair strands are repelling each other. Yes, they are repelling each other. So, what's happening? What's the phenomenon which is occurring? Now, this device is called as Venn diagram generator. Yes, Venn diagram generator. Now, this device is named on an American physicist called as Robert Jameson Venn diagram. Alright, so let's talk about Venn diagram generator. Now, Venn diagram generator is basically a device which produces very high electrostatic potentials of around 10 raised to 7 volts on the surface of the device. Yes, the order is 10 raised to 7 volts. Now, we all know if we talk about air, the dielectric strength of the air is 3 into 10 raised to 6 volt per meter or 3 into 10 raised to 6 Newton per coulomb. Correct? Now, that's the dielectric strength of air. Correct? Now, let's take another conductor of electrostatic potential 0 volt. Correct? Now, let's say the separation between the Venn diagram generator and this other conductor is 1 meter. That means to break this dielectric medium, we require 3 into 10 raised to 6 volts. But because of the Venn diagram generator, the potential difference is in the order of 10 raised to 7 volts. Correct? That means because of the very high electric field produced by the Venn diagram generator, the dielectric medium will be ionized. Yes, it will be ionized, and this process of ionization will cause a current flow from one conductor to the other conductor, and this process is called as corona discharge. Yes, corona discharge. Right. Now, let's talk about the working apparatus of Venn diagram generator. Correct. First of all, the Venn diagram generator consists of one conveyor belt. Now, this conveyor belt is made up of insulating materials like rubber, silk, etc. Right. Now, there are two pulleys on which this conveyor belt is moving. Correct. Now, one of the pulleys is basically connected to a motor which is driving the conveyor belt. Correct. Now, let's talk about these two brushes. One brush is called as the spray brush and other brush is called as the collecting brush. We will talk about the speciality or the function of these two brushes later. Correct. Now, the spray brush is basically connected to a very high voltage direct current power supply. Correct. Now, the collecting brush. Now, the collecting brush is connected to a dome-shaped hollow conductor. Yes, a dome-shaped hollow conductor. Correct. Now, let's talk about the working of Venn diagram generator. We will start with the brushes. To know the speciality of brushes, we will first talk about radius of curvature. Let's consider one conductor. Let's put some charges on this conductor. As you can see that there is a tendency of charges to lie on those areas where the radius of curvature is very less. Because of the low radius of curvature, you can see that there is high charge density on these areas. Correct. That means these charges are lying on those areas for which the radius of curvature is less. That means these areas have very high surface charge density. Correct. And this is the phenomenon or this is the action which is used in brushes. As you can see, the spray brush and the collecting brush are made up of sharp points. That means the radius of curvature here is very low. So the charge density, if I put charges on these brushes, the charge density or the surface charge density will be very high. And because of that, the electric field of this charge density will be very high. Correct. Now, let's talk about the working of Venn diagram generator. Right. Now, because of that high voltage DC power supply, there will be positive charges going from the DC power supply to the brushes, which is the spray brush. Right. Now, because of the very high charge density of the spray brush, the brush will spray positive charges towards the conveyor belt. Alright. Now, this conveyor belt will carry the positive charges from one end to the collector brush. Right. Now, this collector brush again is made up of sharp points. Correct. That means it will easily accumulate all the positive charges. Correct. Now, this collector brush will accumulate all the positive charges. Correct. Now, this collector brush is connected with a dome-shaped hollow conductor. Now, let's revise one principle. In the electrostatics of conductors, we studied that the interior of a conductor cannot accumulate any excess charge. That means all the excess charge will be on the surface of the conductor. Now, since the collector brush is connected to the dome-shaped hollow conductor, the positive charges will try to reside on the outside surface of the conductor. Yes, using that property of electrostatics of conductor, we can say that the positive charges will try to go on the outside surface of the conductor. Alright, so basically the positive charges are going from the collector brush to the surface of the hollow conductor or the dome-shaped hollow conductor. Correct. Now, let's just talk about the surface of the conductor. As you can see, the area of that conductor is constant, right? But because of that DC power supply and because of this mechanism, the positive charges are basically residing on this surface. Basically, the positive charges are adding up on this surface, right? Now, the area is same, but the positive charges are increasing. That means the surface charge density of this conductor is increasing, which is basically uniform surface charge density. Now, let's revise one more principle. As you increase the charges on a surface, the electrostatic potential of the surface increasing. That means Q is proportional to V. The amount of charges as it goes on increasing, the electrostatic potential of the surface goes on increasing. And that's how a Venn diagram generator works. Venn diagram generator increases its electrostatic potential by this mechanism. So basically on the surface of the Venn diagram generator, positive charges are added up, and because of that the electrostatic potential of the Venn diagram generator is increasing. Correct. Now, when you touch a Venn diagram generator, which is basically a conductor, and basically the human body is also a conductor. So basically there's a circuit, right? Now, because of that, the positive charges flow from you towards the strands of your hair. And the strands of hair are also a conducting medium. That means the hair strands will accumulate positive charges. And that is why they are trying to repel each other. And that's how Venn diagram generator works. Correct. Now, let's enclose this Venn diagram generator with a steel chamber. Now, in this gap, let's fill this Venn diagram generator with a nitrogen gas and a freon gas. So basically, the nitrogen and freon gas are basically acting as the insulating material. To stop the leaking of charges or to stop the corona discharge, we are basically now enclosing the Venn diagram generator with a steel chamber. Correct. Now, the gap is filled with a nitrogen gas and a small quantity of freon gas. The nitrogen gas and the freon gas are acting as insulating materials to basically stop the leakage of charges. Correct. Now, let's consider one electrode. This electrode is connected to the surface of the hollow conductor. That means the electrostatic potential of this conductor or this electrode is same as that of the conductor. That means it is in the order of 10 raised to 7 volts. Correct. Now, let's consider an evacuated tube. Now, evacuated means the tube has vacuum, right? That is, there is no air molecules, right? Now, if I keep a proton here, because of the very high electrostatic potential of this electrode which is connected to the Venn diagram generator, this proton will be repelled with a very high electrostatic force. Yes, it will be repelled because of the very high electrostatic potential. So, if I keep a proton or a helium nuclei or any positively charged particle, that positively charged particle will repel with a very high electrostatic force. That means it will be accelerated in the downward direction and it will gain some kinetic energy. And we can use Venn diagram generator and we can use these high energy particles to study the nuclear reactions or the nuclear structures or the radioactive isotopes and many more. Alright, so this was all about Venn diagram generator. Alright.